Now this question reads as the isotherm. Isotherm means constant temperature plot. It is at constant temperature. What is the variation of PV product against P? X-axis is only pressure. Y-axis is the product of pressure and volume. So PV variation with pressure at a particular temperature, it is given. At a particular temperature means it is isotherm. So carbon monoxide isotherm is given in figure. In this figure, the question asked is, in this figure, near the point A, the compressibility factor is dash. There are 4 choices given. So in this figure, which shows the isotherm of carbon monoxide at a particular temperature. Temperature is not, because it is at a constant temperature, not be repeated. It is given. So you have to take the normal equation. P plus A by V squared into V minus B equal to RT. This is one type of equation. So Van der Waals equation. This Van der Waals equation, normal pressure conditions, it is normal pressure volume conditions, any system, it will definitely obey Boyle's law. It need not obey Charles' law, Avogadro law, anything. So everything we have to be noted. Boyle's law. Actually Boyle proposed the law based on the behavior of gases. That's why definitely any gas will obey Boyle's law. So at normal conditions, as pressure increases, volume decreases. Pressure decreases, volume increases. So this is another case compared to the previous question. This is the case where P plus A by V squared cannot be neglected, but V can be high compared to B. B is called cohesion volume. Van der Waals constant, volume occupied by 4 single molecules. Volume occupied by 1 molecule is very low. Let us consider for the simplicity, water contains H2O whose molecular weight is 18, which means that 18 grams of water contain 6.023 into 10 power 23 molecules. The same sentence can be put in otherwise. The weight of 6.023 into 10 power 23 molecules is 18 gram. Then weight of 1 molecule is nothing but 18 divided by 6.023. 18 by 6 is 3. 3 into 10 power minus 23. The single weight is very low. That is to be noted. So volume occupied by 4 molecules is very less compared to actual volume of the gas. So, or in other words, for this case, this V is very high compared to B. So that B is neglected. In this case, only B is neglected. So P minus B is approximated as V because we are neglecting B. So it is resubstituted. P into V, PV, AV by V squared, A by V equal to RT. In a similar manner, you can divide by RT. PV by RT, A by V into 1 by RT, RT by RT. RT by RT is 1. So you can simplify. PV equal to RT minus A by V plus A by V, opposite side it becomes minus A by V. Now fully divide by RT, last equation. PV by RT is nothing but Z. PV by RT equal to definition Z, compressibility. RT by RT 1 minus A by V into 1 by RT, or in other words 1 minus A by RTV. So 1 minus A by RTV is given as the last choice. So for this question, last choice is the correct answer. So in this way, you have to substitute for the high pressure or high temperature, low pressure conditions. It is not never the temperature. We are not manipulating the temperature. That is because it is isotherm. Isotherm means constant temperature. Only pressure volume relations have to be properly looked into. Whether the pressure is very high or pressure is very low. Accordingly, volume will be following different sense. Which is to be neglected, it has to be carefully dealt. So this finishes the fixing up of the choice. Here it is isotherm. This is based on the comparison of ideal behavior of different gases. So the question reads as maximum deviation from ideal behavior is expected for dash. So the question is written in a condensed manner. So which of the following, actually the question is which of the following gases shows maximum deviation from the ideal behavior? That is the question. All are gases: methane, ammonia, hydrogen, nitrogen. First we have to recall the condition for ideality. So condition for ideality is that molecules should be freely moving. Which molecules are more freely moving? They are more ideal. So that is why condition for ideality is that high temperature and low pressure. Under the conditions of low pressure, volume is very high, enormous space is available for molecule to move, so it can move freely. High temperature, kinetic energy is high, of m squared is high, v squared is high, v is high, that is velocity. It moves with the maximum velocity. That also explains. Under these conditions, so the ultimate condition is that molecule should be free to move. Maximum freedom is there for a particular molecule. There it is said to be ideal. In cases, let us compare. So methane, ammonia, CH4 is methane, NH3 ammonia, hydrogen molecule or dihydrogen H2, dinitrogen or nitrogen molecule or N2. So gases are divided into two types. Permanent gases, gases having affinity towards water. Permanent gases means they do not have affinity towards water. Methane does not have affinity towards water. Even if you mix with, what is meant by affinity? Combining capacity, at least physical combining capacity with the water. If it is forced to be in with water, it will be waiting for us to escape from water. Even if you open, water will remain in the container, gas will be escaping. But ammonia will not escape. Ammonia will have a greater affinity towards water, so that it forms. We have seen about some reaction. If you write this reaction, ammonia formula, water can be written as HOH. So there is actually a chemical reaction between water and ammonia. This is called ammonium hydroxide. So ammonia, H2O is nothing but water. Ammonia dissolves, H3 plus 1, H4. So NH4OH. So there is a chemical reaction takes place, means that there is a greater binding between ammonia molecule and water molecule. Or ammonia molecules are attracted by water molecules, they are held into the water molecules, they cannot move freely against water. Whereas other three gases, there is no reaction between methane and water, no reaction between hydrogen and water, no reaction between nitrogen and water. So methane, hydrogen, nitrogen, these are called permanent gases. Permanent gases means they retain their mobility even in water medium. So they will definitely escape from water, whatever will be the condition. But in the case of ammonia, if it is mixed with water, water molecules will attract. Water molecules cannot attract this because water is a polar solvent. Ammonia is a polar molecule. Methane is a non-polar molecule. So polarity means in the case of covalent bond, there is more electronegative atom will attract the central electron pair. That is called electronegativity. We have studied in periodic table. So here carbon is more electronegative, but it cannot show. It is strictly a covalent bond. Hydrogen contributes its only one electron. It cannot afford to lose its one. The carbon has 6 electrons. Each hydrogen atom contains only one electron. That only it is given for sharing, but it cannot lose that one electron also under the name of sharing. So there is no polarity in the case of methane or hydrogen. Both hydrogen atoms are equally powerful. They will tend to attract their own electron. They will not attract other electron. Cannot be attracted. So these are called homonuclear molecules. Molecule made up of same atoms. Molecules power is same. If the power is same, it is equivalent to rope pulling on either side. Rope is pulled by the same hydrogen on either side. Rope here it is equal to electron pair. It will not move. It will only be at the center. These are permanent gases. But ammonia, nitrogen is more electronegative. So nitrogen has lone pair of electrons. Nitrogen valency is 3 or 5. So here it shows only the 3 valency. There are two more electrons are there for, so this there is a greater affinity between ammonia and water. It is also a polar molecule. It is also a polar molecule. So because of polarity, there is interaction. Because of this interaction, ammonia molecule cannot escape easily or move freely in the water medium. Even in water medium, methane can move. Even in water medium, hydrogen can. If it can move, means it behaves ideally. If it cannot move, means it deviates from ideality. Ideality means deviation. Deviation from ideality means that it cannot move. Which of the molecules cannot move in water? We have to compare. Under this comparison, this ammonia. So for this current question, ammonia maximum deviation occurs only for ammonia, because the reason is ultimately ammonia is a polar molecule. Water is a polar solvent. Like species have attraction. If there is an attraction, it cannot escape. If it cannot escape, it cannot move. If it cannot move, loses ideality. That is to be noted. This for this question. So maximum deviation from ideal behavior is expected for ammonia. So this finishes the analysis of this question. Now this question is based on the Graham's law of diffusion. This question conductively put manner 50 ml of two gases A and B. 50 ml of two gases A and B, their rates of diffusion is compared. So rate of diffusion means actually in a container both the two gases A molecules as well as B molecules are kept. There is a hole provided, small hole provided. So they are allowed to escape. So each molecule, each gas can be identified by one or other method, because one molecule, even just now we have seen. So let us take the case of ammonia and methane. Both are gases. If you absorb in water, ammonia will be better absorbed in water. Methane will not be absorbed in water. By some means, they can be properly absorbed. That is different. But what is the diffusion rate they are comparing? How it is diffusing? Diffusing means escaping tendency from a container. The question asked is, question is reads 50 ml of two gases A and B, take 150 second and 200 second respectively to pass through a hole provided at the container. So we have a container like a cylinder. There is a small hole kept here. If there is a small hole kept in the cylinder, definitely gas molecules will escape. All the gas molecules will escape. But the rate of their escaping is different. Heavier molecules will move slowly. Lighter molecules will move fastly. Affinity towards atmosphere will move fastly. There are variety of factors. Here they are comparing. So the question is 50 ml of two gases A and B, take respectively 150 second and 200 second to escape through a small hole in a container. Initially they are kept in a container, small hole is made, their rate is measured in terms of flow time. It takes 150 seconds, it takes 200 seconds. Molecular weight of gas A is given as 36. Molecular weight of gas A is given as 36. Molecular weight of B is asked. So there are 4 choices given for the answer. So once again, two gases A and B, total volume is 50 ml, is kept in a container. Container is provided with a small hole. Both the gases will escape, but both will not escape equally. That is to be noted. Both will escape. Lighter gas will move faster, heavier gas will move slower, or better affinity gas will move faster. There are different conditions. So we don't know about the parameters. Just it is mentioned as A and B. A takes 150 seconds to escape, whereas B takes 200 seconds to escape. What is meant by how? A and B. It is absorbed in a different container. One container absorbs A, other container absorbs B. Here the distance is not, they are kept, it is, you should not mistake, it is in a different distance. They are allowed to go through only one distance. It is like a parallel connection. So each A rate at what time A is absorbed, at what time B is absorbed. These are given, and it takes 150 seconds for A to fill the container, whereas it takes 200 seconds for the other container to fill it up. So we are providing with two types of container, or in other words, there are different methods. Actually, gauge meters will be provided. Pressure gauge meters for two different things will be fast. So each of them which is moved faster, that will be collected in different arrangements. Our aim is to compare the rates of diffusion. How quickly diffusion means capacity to escape from the container. Capacity to escape from the container. Even in the normal case, if you make a puncture in the tube, suddenly it expands because it is forced at high pressure. But normal cases, they will not, even though whenever we study about gases, some gases are considered as lighter than air, some gases are considered as heavier than air. Those which are lighter than air will move slowly, fastly. Those which are heavier than air, they will move slowly. Even in the plate, etc., you can observe some smokes. Smokes will not be immediately spread. Jet plane, the smoke is exhaust gases. It will be slowly be spreading. It is only gas. It cannot quickly escape from the system. So there are some gases we are comparing. One takes 150 seconds to escape, whereas the other gas B takes 200 seconds to escape. The molecular weight of A is given as 36. B we have to find. So here Graham's law of diffusion is to be applied. Graham's law of diffusion states that the rate of diffusion of a particular gas is generally rate of diffusion of a gas is inversely proportional to the square root of density of the gas, or it is inversely proportional to the square root of molecular weight of the gas. So this is the statement. The rate of diffusion of a gas through a system is inversely means 1 by proportional to square root of either density, molecule. If density is known, you can compare. So this is meant by the mathematical statement, Graham's law of diffusion. This D stands for the density of the gas. Here we have two gases, A and B. Let us compare their rates. RA denotes the rate of diffusion of gas A. RB denotes the rate of diffusion of B. So you can write in this, let us apply only one. Rate is inversely proportional to square root of molecular weight, because molecular weight is given. Or in other words, rate equal to some constant divided by square root of molecular weight. Rate equal to some constant divided by molecular weight. You can apply this formula. RA equal to some constant, let it be K or something. So some constant, let it be K. So K by root MA. This is one equation. Then the same Graham's law of diffusion can be applied for the second gas, that is B. You can write RB equal to same gas, constant will not differ. It is K by root of MB. One equation, two equation. So first Graham's law applied to the first gas A. Graham's law applied to the second gas B. So equation 1 divided by equation 2. Left side you divide RA by RB. Right side 1 by root of MA divided by 1 by root of MB. 1 by root of MB, it becomes, so or in other words, RA by RB equals root of MB by MA, inversely proportional. That is to be, the denominator goes to the numerator, MB by MA. So just application of the Graham's law for the individual gases, or you got to note down the net results. Whenever rates of diffusion of two different gases of variable molecular weight are considered, RA by, it is inversely proportional. You can directly write rate A is inversely proportional to its molecular weight A. Rate B is inversely proportional, means here it is in the denominator, here it is in the numerator. Here it is numerator, Here it is denominator. Inversely proportional means they get exchanged. Direct proportion means it will be directly RA by MA, like that. So that is to be noted. So the final result you have to bear it in mind. RA by RB equal to root of MB by MA. RA is denoted as rate nothing but flow time. RA is 150 second. A flows in 150 second. RB takes more time, 200 second. 200 equal to root of MB we have to find M. MA is given as 36. MA is given as 36. Now 350s, 450s. 3 by 4 equal to root of M by 36. So let us hereafter only algebraic. You take square on both sides. 3 squared 9 by 4 squared 16 equal to, if you take square, root will be going, that is M by 36. This on simplification we want M, that is MB, M or MB, whatever be the case, equal to 9 by 16 into 36 by 36, opposite side into 36. So 4 fours, 9 fours. 9 fours are 36. 4 fours are 16. 9 into 9, 81. 81 by 4. Roughly 80 by 4 is 20. Nearest value is given as 20. So here you have to carefully apply. The Gregham's law of diffusion states that rate is inversely proportional to square root of densities. On the other hand, if it is if you are writing as such, you may not find the answer. Sometimes they will give all the possible answers. If you work out the ratio is inverted and if we commit some mistake, M will be given as 64. 64 will also be there in the choice. You will be tempted to, oh, our choice has come. It should not be the case. You have to be thorough about the Gregham's law of diffusion. So Gregham's law of diffusion, rate of diffusion of a gas through a medium is inversely proportional to square root of density. That is important. Square root of density or square root of molecular weight. Accordingly, you can write it and apply the given data to arrive at the result. So for this question, so the molecular weight of gas B is around 20. Around 20. A is given as 36.